Hello everyone, welcome to the next topic that is Introduction to Deep Q Learning. So in the previous lectures, we have already studied what is Q learning. So before moving on to the Deep Q learning, we'll have a short introduction of what Q learning is. So Q learning is a basic form of reinforcement learning which uses the Q values, or these are also known as the action state values, which helps to improve the behavior of the learning agent. Now the two basic points which it covers is the cue values or the action values, and second is the reward and punishments. Next, the what are the cue values or the action values, and what are the rewards and episodes. So cue values are basically defined for the states and action, and it helps to estimate how good it is to take the particular action of for that particular state. So it is just a mapping from one state to the action. And second point, we have the rewards and episodes. So the rewards and episodes basically helps for making the transitions from one state to the next state based on the choice of action. And it also helps us to see the environment in which the agent is interacting. So this is the definition, or these are the 2 points which are under the Q learning. Q values and the rewards and punishments, or the rewards and episodes. The third one, we have temporal difference or the TD update. So as we have already seen, we estimate the value of Q. So we can say the value is getting updated, or the value can improve at every step of the agent interaction. So this value which we have updated and the value which we have already calculated is defined by the term temporal difference, or we can say the TD update. So when we are updating the value to estimate the value of Q, that is the mapping from the states to the actions. Next, the Q value or the Q learning, it helps to choose the actions for taking or use. It uses the greedy policy. Next, with probability chooses the action which has the highest Q value. So if we map the values, we define the value function, and then we choose the actions which have the highest Q values. The third point is with probabilities, choose any actions at random. So when we have the probability, we can choose any action at random also. And then we can see how this model is helpful for improving the learning for that reinforcement model. Next, we have the deep Q learning. Now, the Q learning, what it does is it creates an exact matrix for the working agent, which it can refer to maximize its rewards in the long run. But this is only practical for small environments. But when we have the large or the number of states is high, we cannot map or we cannot update the values or the Q function for every state to action mapping. So in that case, what we do is we use the deep Q learning. So we can say the solution for the above problem comes from the realization that the values in the matrix only have the relative importance. So thus thinking leads us to the deep Q learning, which uses a deep neural network to approximate the values. So here we have the large number of values, so we'll be using the deep neural network to check or to approximate the values. The third point is this approximation of value does not hurt as long as the relative importance is preserved. So we are using the deep neural network, so it will help us to estimate the values for large number of states. So the working of the deep Q learning basically starts with the initial states. So we feed the initial states to the neural network, and then it returns the Q value for all the possible actions which are as the output. So we can check whether it is improving the environment or not. So this is a small diagrammatic difference from between Q learning and the deep Q learning. So for Q learning, we can see we have state actions and we have Q values. So this is a matrix and we have the information stored in the form of matrix. But when we have a deep neural network or we have multiple states, we have different mappings from state to actions. So every state from one node to another will have a different Q value or the Q value action. So you can say we have different Q value actions, and you can also check this is a complicated network. We can say this is using a deep neural network. So this is the difference between the Q learning and the deep Q learning. So what we have covered in this slide, in this content, is what is Q learning, difference from Q learning and deep learning, and the diagrammatic representation of deep learning and Q learning. So this is all for the content, deep Q learning. Thank you.